Alright, in this video we have f of x equals 1 over the square root of x, and we want to find the slope of the tangent at x equals a. Okay, so slope of the tangent, that means derivative, take the derivative, right? And so with the limit definition we have f prime of a, right? We're interested in x equals a, right? So f prime of a is the limit as h approaches 0 of f of a plus h minus f of a all divided by h. Okay? So let's plug in what we know. Limit as h approaches 0. What is f of a plus h? Well, just plug in a plus h into here and you have 1 over the square root of a plus h. Okay, minus f of a, that's 1 over the square root of a. And that's all divided by h. Okay, so this doesn't do much good for us because we can't plug in h equals 0. That would give us divide by 0. We don't want that. So we have to do something with the numerator. And so they have different denominators, right? One has an square root of, one has a square root of a plus h, and one has a square root of a, right? So we're going to get a common denominator. This is the first algebra trick that this problem requires. We need a common denominator. Okay, so we have the limit as h approaches 0. Okay, I'm going to write the two terms that we have. Okay, so if we want a common denominator, then this is going to need a square root of a, and this is going to need a square root of a plus h, right? And so to legally do that, here we have a square root of a on top, and here we have a square root of a plus h on the top as well. All right, we can't just add in terms wherever we want, right? We have to multiply by 1. This is all over h. Okay, so now limit as h approaches 0, square root of a minus square root of a plus h. That's the top, right? And then on the bottom we have that combined denominator. Alright? And then this is all divided by h, so I could divide it all by h, but I'll just put it right here. So we still can't plug in h equals 0 because we'd have divide by 0. So we have to do another algebra trick. Okay, so what we're going to do is multiply by the conjugate of the top. Alright, so the top is the difference of some square roots. So we're going to multiply by the conjugate, which is the same terms but with the sign in the middle flipped. Alright, so we're going to multiply by square root of a plus square root of a plus h. Okay, so we're going to rationalize. Alright, so we have the limit as h approaches 0 of square root of a minus square root of a plus h over h square root of a square root of a plus h. And now, okay, we're going to multiply by the conjugate. And again, we have to divide by it. Multiplying this by 1, right? This would be 1, but this is going to help us. So we're going to carry out the multiplication up here. Alright, Alright, so square root of a times square root of a, that's going to give us an a. And then square root of a times root a plus h, that's going to give us so plus root a times root a plus h. And then we're going to have a minus root a plus h from this term times this term. And then we're going to have a minus quantity a plus h. All right? That's from these two terms, the negative root a plus h and the positive root a plus h. And we have this this whole denominator, right? So that's going to be h. So I'm multiplying this part by root a. The root a's are going to become just an a. So h times a times root a plus h. Plus, okay, so now root a plus h times root a plus h. That's going to become a plus h. Alright, so there are a lot of terms here. It's really easy to get bogged down in the algebra. So just be careful when you're going through this. But now, if we look at the top, so this always happens when you conjugate something. You're going to get a cancellation. If you don't, then something went wrong somewhere. You're going to get a cancellation. Alright, so these two terms cancel. And there's another cancellation, but let's rewrite it first. So we're going to have a, and then we have minus a minus h. Right? Over both of these terms have an h, so I'm going to factor it out. So over h times a root a plus h plus root a times a plus h. Okay? I just pulled an h out from both of these denominator terms. Okay? So we get another cancellation. These a's cancel. So now we have the limit as h approaches 0 of negative h over h times a root a plus h plus root a times a plus h. And this is the key cancellation when that h term disappears from the denominator. Okay? If that doesn't happen, then either something went wrong or you're not going in the right direction. Got to get that h to disappear from the denominator. Now we have a negative 1 on top, and we have a root a plus h plus root a times a plus h. Okay, so now we can plug in h equals 0, right? We're not going to get 0 on the bottom. That's the key thing. If this h was still hanging out on the outside, if we plug in h equals 0, we'd be dividing by 0, which we can't do. But we got rid of it, so we can plug in h equals 0. So this limit is going to equal negative 1 over a times root a plus 0 plus root a times a plus 0. That's going to be negative 1 over a root a plus a root a. These are the same thing, right? So we have two of them. Negative 1 over 2 a root a. So that's negative 1 over 2 times a to the 1 times a to the 1/2. So we have two a terms. We're going to add the exponents and get negative 1 over 2 times a to the 3/2. Okay? You could also write that as negative 1 over 2 times a to the minus 3/2. So this is the answer right here. Alright, so a ton of algebra, two key tricks. common denominator, and then multiplying by the conjugate to rationalize the numerator. And then it's just a bunch of algebra. You got to be very careful with how you cancel out your terms, and you got to be very careful to distribute the minus signs. The key checks along the way are that something cancels after you rationalize, and then near the end you want those h's to cancel to get rid of the h that's on the denominator. Those are the key things to check when you're working through these really long limit problems.